15 from yesterday. I went over 6 yesterday, I feel like. Yeah. I heard Miss McGee. Yes, you may. All right, so this is intercept form, yes, because there are 2 parentheses. That gives us 2 points. What are the 2 intercepts here? -2 and 1. So I'm going to graph those. Here's 1, 1, 2. Now I need to find in the middle of those 2 points because I need the axis of symmetry. So how do I find in the middle of 2 points? There you go, average them. So -2 plus 1 divided by 2, which is -1/2. That's going in my equation in order to find the y. So I end up getting negative, this would be 1.5, -1.5, 15 times 15, 222, no, what is it? 2.25, is that right? I was doubting myself. Well, 2 negative, yeah, so positive. So it's going to be positive. So I'm going to go 1, 2, and 1/4. Does it do everything that it is supposed to do? Is it up and down? Is it average width? And are the intercepts correct? Yes. Does that answer your question, Miguel? Anything else from the packet yesterday? You got it wrong? I'm sorry. One of the standards? Sure. Give me one. Anyone, no matter. Okay. Number 13. Y'all got that? Number 13. You are due for a quiz, but I'm gonna wait until you can do the domain and range on it as well. Today. Domain and range today. So probably quiz on Monday, yeah. All right, let's find the vertex first. Opposite B over 2A, which would give me +2, yes? Negative divided by a negative there is a positive. So I get 1, 2. Plug that 2 value in to find the y that corresponds to it. So be careful of that negative that sits in front, right? This is not the same as this. So be careful. This says no matter what the answer is, make it negative in the end. So this is going to be -2 squared plus 4 times 2 minus 1. If you use STO on your calculator, this would be an easy point to get the answer, but that's okay. For -4 plus 8 is 4, minus 1 is trace. 2, 3. 1, 2, 3. Easy point, what shall I use? -1. Not the vertex, so that's an easy one to use. I'm going to go down to 1, and I'm going to reflect, and everybody say it together. Connect, thank you. By everybody, I meant Sully. So thank you, Sully. Yay, nay. Yay. I'm sorry. But what's going to happen is you'll generally always be given them in standard form, and then you'll manipulate them to another form eventually. Which is funny because whenever we get to Unit 2, calculus was doing a quadratic, I think that was calculus this morning, a quadratic formula this morning. And I was like, I tried to tell y'all, it's the algebra 2. Algebra 2 never goes away. Oh, I know. I know. All right, what else? Anything else before we move on? Good. Going once, twice, 3 times a lady. Let's go. All right, let's talk about functions in domain and range. I would ask y'all if you need a break, but I think y'all been on break since y'all got in here. So, okay, so the first day, remember I asked you, did you need a break? And y'all were like, now y'all are like, we need a break. We need a break. I knew it wouldn't last long. A day. What'd you say? That was the first day. Y'all had to fill it out. Do you really think T got in trouble? If you all make 100, I don't know, but I do bring them in occasionally. Metaphors. The little cakes I make. No. Y'all ready, or am I losing my mind? I'm pretty sure, didn't we do like the T-chart and talk about if X repeats or Y repeats, and we talked about the map? My goodness, everything's blurring together. Okay, tell me what it means to be a function. What makes it a function, or what does it, qualifications does it have to meet to be a function? It has to be what? Non-repeating X. Okay, give it to me. Okay, so there's one and only one output. Whoa. Come on, Stacy, spell it right. Output. For each. Do I need to write in print? We are, but we need to learn about functionality first. Am I? If you do AP calculus, that's all you want. Yeah, you won't catch me in that one. Well, I've heard that. Or they go, I can get that. Players? Stay up for the video. Oh yeah, quite a few. One output for each input. That means every X has a unique Y value. If you're looking in terms of a table, I'm gonna give you two tables here. The first one, function or not. But I see two outputs that are the same.
X doesn't repeat though.
X doesn't repeat because every X can only have one and only one output. So one only has one output, two only has 1, 3. But over here, the 3 could be 1 or 2, so it has two outputs. So this one is not a function. So it's kind of easy to look at the table and tell, but what about graphically? What if I was looking at this on a graph, how would I tell? There's a test you can do.
Calculate.
Vertical line test. So tell me if I scroll too fast too. Graphically, vertical line test. What? You need me to go back? So that means anywhere on the graph that I go, if I drop a vertical line, if it ever intersects more than one time, then not a function. If a vertical line, if you can drop a vertical line anywhere on the graph, vertical up and down. Think about a V looks like an arrow up or an arrow down, right? Vertical's up and down. This is how I remember it. Vertical looks like an arrow pointing down, right? So it's an up and down. Horizontal has this big line. There you go, horizon. There you go. Go in Canvas and click the link that says notes. But when you're in a T-chart, yes, the X should not repeat. But graphically, let's say this was one, and then let's say this is another graph. The first one is a function, yes. Everywhere I take your pencil, hold it up and down, go left to right or right to left, it doesn't matter. There's nowhere on that graph you could lay it where it hit more than one time. But this X has 3 different Y values that go with it. That one input has 3 outputs. So that one's fine. All right, everybody good? Hold on, I'm coming, Doja. Completely new first, so I need you to stay with me for a minute. Okay? Try your best, Lily. That's all I can ask. Is that chair more comfortable? Okay. Hey, I see somebody. Is that a beaver? Oh, that's a dog.
No. No.
It's a little dog. Okay, it's a tiny dog.
No. Okay. Oh, there's someone else.
How many of you have seen interval notation before?
What?
Okay. This is how you are going to write your domain and range from now on. This is a more sophisticated way to write inequalities, essentially, is what it does. So I'm going to show you some inequalities. We're going to relate them back and then try our best to do this. All right, let's think for just a minute. If I have X is less, this is just the title heading, by the way, interval notation. If X is less than 3, if I were to put that on a number line, you're exactly right. So when you say circle it, tell me what you mean. Okay, so when do you do what? If it is less than or greater than, it's an open dot, right? But if it's less than or equal to or greater than or equal to, we fill it in. Why do we fill it in? So you know it includes that number, right? Okay. Just gonna make a TikTok dance. Shut up, Sid. Just tell me shut up. Okay, so now I need to draw the arrow in one direction, right?
Probably has some one direction or something.
Okay, which way do I go? Because this says X is less than 3. Which way do the numbers get less than? To the left. Are we all in agreement here? I'm going to now tell you, well, before I tell you that, would it make, have you ever seen this symbol before? Infinity, duh. Okay. I'm going to tell you that to the left, if you keep going forever to the left, that's negative infinity. Would that make sense to you? And if you keep going to the right forever, that's positive infinity. Would that also make sense to you? Okay. You've heard this before. Okay. I bet you haven't heard what I'm fixing to tell you.
So, since there's infinite numbers between 0 and 1, and there's also infinite numbers between 0 and 2, does that mean that infinite amount of numbers between 0 and 2 are bigger than the infinite amount of numbers between 0 and 1?
You should definitely take calculus because we address this. We talk about, I'll have to read you my infinity story about the hotel infinity. And infinity raised to infinity bigger than infinity because at the end of the day, they're all just infinity, right? And if you can hold infinity number of people, could you hold infinity number of people plus 1?
Unpopular opinion, infinity's not real.
It's conceptual. It's conceptual. It's conceptual.
Nobody can count that here.
Okay. It's conceptual. It's an ideal. Yeah, it's a thought. It's not an actual value. It's a fact, but it's not. Okay. From now on, instead of less than or greater than, I am going to tell you to use parentheses. One of the two ways. And instead of less than or equal to or greater than or equal to, I'm going to tell you to use brackets. Okay? This is going to indicate exclusive and inclusive. That's exactly right. I told you I was going to teach you something new. You're not going to like it at first, but it is so much easier and better and more concise. Okay, so instead of this open dot, I'm going to do a parenthesis, and I'm going to open the parenthesis in the direction that the numbers go. Okay, so in other words, they go to the left, so I'm going to open it to the left. So now in interval notation, and by the way, anytime I reference infinity, do you think I'll be using exclusive or inclusive? Exclusive. Can you be infinity? No. We just talked about that. You can't actually be infinity. So conceptually, so anytime you use an infinity or a negative infinity, those are exclusive. So either way, yep. So if I wanted to write x is less than 3 in interval notation, always go smallest to biggest. What is the smallest value that x can be? Negative infinity. So I'm going to start with negative infinity. Nope. Smallest to biggest. Then you use a comma, okay? We only have two sets of numbers in here. I'm going to use a comma, and then I'm going to say it keeps going until I hit what? 3, and it stops. Does it include 3 or exclude 3? X is less than 3 can be written as negative infinity to 3. Okay, it's not bad yet. Well, you're going to be able to write any inequality at all. You'll be able to write in interval notation. Let's do it. This is harder than this is the hardest to teach than domain and range or this, because this will take the longest because you've never seen it. Okay, let's say I want to do x is greater than or equal to, bless you, -4. Write that in interval notation form. Don't blurt it out when you get it. If you need the number line, do the number line. Sometimes it's helpful. You'll eventually get to where you don't have to do the number line anymore. What'd you start with? Bracket. -4. Not bracket. Infinities always get parentheses. When it. Why is it not what? Infinity. Yep. Infinity will always be exclusive. Always the smallest. It's always smallest to biggest. Yes, there will be. Yes, we're going to do this. Yes. Yeah. Well, what if I said, yeah. Domain and range. This is how we're going to do domain and range. If I say, what's the domain of the function? What's the range of the function? I'll show you. That's what you just asked.
If you want to do a good job in mathematics.
It teaches you to be a problem solver. A real life example of this? Of what? Domain and range. Domain and range, you restrict things all the time for domain and range. And that's what we do with domain and range. Well, we use this in all the other applicable stuff. So we use it for domain and range. But this is, if you go into engineering or anything like that, or any type of mathematical, this is the accepted, like, we don't use that anymore. All right. What if I think this is what you were asking.
Oh my gosh, you want me dead.
If you just have one, if there's only one number in your domain, there's one number and nothing else, it would just be that one number. Like, you wouldn't have, you won't encounter that very often. If you're confused, put it on the number line and it'll make a lot more sense to you. I hope. And I hope you all can graph that on a number line. What does it look like in interval notation? Does that make sense? Are you sure? Okay, I got two more things to show you with interval notation. What if No. Mm-mm. Yeah, that's not much. It's not much. Y'all got that now? You don't get it, or you hadn't copied it? Oh, okay. Okay, hold on. Let me show you something else. Remember when you did compound inequalities in whatever grade that was, and you did ands or ors? That was an and that we just did. When I used to teach foundations, we did ors. I called them chicken wings because they look like chicken wings on the. Let's say this is why. I always drew my lines above like this because so you could see them. That's why I called them chicken wings. What if I needed to write this in interval notation? There's two pieces here, right? It's not just one anymore. So I need more than one. I can only put two numbers in an interval. So I'm going to need two sets. So I join, and I hate they don't teach set notation or sets anymore in elementary school because it used to make a lot more sense. But what I do when I need to join more than one set, join sets with a U. And what this U stands for is union. We used to talk about union and intersections of sets, but for some reason sets have gotten taken out of standards. I don't know why, but whatever. So if I needed to write this one in interval notation, here's what I do. I'm going to describe this one first. Remember, I start with the smallest value it can take on. So what's the smallest? Negative infinity. And infinities always get parentheses, right? And then I do a comma, and that tells me to keep going up until I get to what? To negative 2. Negative 2 is where it's going to stop. Do you agree? Okay, so I'm going to put negative 2, and I'm going to tell it to stop. But then I'm not done because, yeah, I stop and I skip some space, but I pick back up at 10. So I'm going to put a U in between, and then I'm going to do, what do you think?
comma, infinity. Right.
In inequality, this would be x is less than -2, or it's one of those ors that you did when you did compound inequalities. Okay. What if there are no restrictions? What if I could be anything in the whole wide world? Is that thing blinking? Y'all are saying infinity, but I'm talking about, how would I say all real?
Oh, the symbol,
In interval notation. What's the smallest it can be? Keeps going until what's the biggest it can be? Okay? I just spent a long time showing you this new notation that we're now going to use for domain and range. Okay. Yes.
Are we ever going to get a question where it's just like,
Yes, that's set notation, not. But yes. So it says X is a member of the real number set. Okay. Let's talk about domain and range. I hope y'all at least know some of this already. Tell me what domain is. Tell me what domain does. What does it describe? It describes X, or, that's right. X is the input, so AKA input. I need to go, when I look at this, I look left to right. So let's talk about a parabola that we have been looking at so far. And let's define range and then we'll do them both together. I think that'll be. If up and down, that's exactly right. Describes y and I look not from, it is up and down, but I start with the bottom. I always say bottoms up on range. From the bottom up. Okay, start with the very lowest point it can be and go up. So let me show you the parabola and let's talk about how we define the domain and range. You'll have some kind of funky graphs for homework that you're going to look at. You're going to tell, is it a function or not? What is its domain and what is its range? They're already graphed for you. Yeah, shouldn't take long. All right, so let's look at a problem. Y'all got that? Okay. Yes. Say this graph goes by ones. This is a parabola that we have been looking at. You have to also understand how the parabola is working. It's still inching out as you go up. It's just not going out as fast as it's going up, but it's still going out. So left to right for domain. Any ideas? It is infinite. Your domain here is negative infinity to infinity. Okay, so left to right. What's the furthest left the graph ever goes? Well, it's going to, right, because you see it's continuing to inch out as it goes up. And because those arrows there indicate that it does that forever, well, I'm back to my infinity concept, right? So it's going, even though it's going up and over, right? Then, as I move right, there's never a place that the graph stops. I'm going over and over. Well, it's still, even all the way over here, there's graph that goes with it. It's just way up there. So left to right. Range, however, is bottoms up. What is the lowest? Remember, range is y. So I'm talking about y values. 1 is the lowest it goes. Does it include 1? Yes, there is a literal fill-in point there. So yes, it includes 1. So 1 needs a bracket, and then it goes up forever. So it's in domain and range. Is it a function? Yes or no? What's the domain? What's the range? Yes. Let's do another one. Pretend like that goes all the way over there. Is it a function, yes or no? Defend your answer.
Yes.
Why? I hear both. It's still going to pass vertical line test, right? Yep, it's a function. Continuity has nothing to do with functionality. Just because it doesn't go on forever doesn't mean it's not a function. Okay, so yes, it's a function. Everybody in agreement now? Yeah. How about the domain? It's weird. Left to right. What's the furthest left the graph ever goes? -2, right? Does it include -2 or not? Yes. So I need a bracket. Now keep moving right. It stops here. How about the range? You're exactly right. Sorry. Unless there's an open dot there. You can have open dots on. One more. Uno más and I'll be done. Uno más, uno más, uno más. This is what the graph of the square root of x minus 2 minus 1 looks like. You don't have to know that. I just wanted you to know there was an equation. Yeah, but we're going to do the domain range for this. First of all, we're going to do functionality. Is it a function? Yes, it's a function. Why is it a function?
That's the vertical line.
Passes the vertical line test is a perfectly acceptable answer. Or because every input has one and only one output. It is curved. It is curved. It goes off the ledge. I'm not saying domain. That's not an acceptable domain. Okay, wait. Bracket 2 to infinity. That's right. Range. Good job. I told a story. I want to do one more. I want to do a circle. Maybe an ellipse. I'm sorry. I apologize. Okay, how have you been drawing it? Y'all eager beavers? Wait, I take your nickname away. I now give it to Oh my goodness, because I can't draw a circle.
Use the circle tool.
That's
All right,
worse.
just use the circle
That's
tool.
yeah.
Just use the circle tool. All right, just use the circle tool. Just use the circle tool.
Just leave it like that.
It's an oval though, because it's 2 by 3.
Still not a function.
Still not a function.
It's still not a function. Why is it the same?
I don't think it is.
Why? Okay, so why is it not a function?
It doesn't pass the vertical range test.
It doesn't have the vertical range test, but it still has a domain and range, yes? Sure, because just because it's not a function doesn't mean it doesn't have a domain and range. What is the domain? -3, 3 brackets or parentheses. Range. What is it? Somebody said it. -2 to 2. With brackets.